guys, it's IDW, and today we're going to be talking about multi-core computers and the memory hierarchy. Today's episode is going to be focused back on some more advanced hardware we never talked about in my computer functions series. This video will outline more advanced topics that I will not cover in Minecraft because I have already been over all content relevant to that computer. So without any further ado, let's talk about multi-core processing. Multi-core architecture is actually pretty simple. The idea is to use more than one processor interacting with the same memory. This can speed up computers considerably because they don't have to do every instruction one by one, but can do multiple instructions at the same time. The way that a program uses these cores depends on the architecture of the CPU. Some CPUs act as one extremely fast processor, while others act as many small individual processors. On to memory hierarchy. We have discussed the differences between different kinds of memory such as RAM and registers before. Your registers should store pointers while your RAM should store data. More complicated computers have many different kinds of memory because of a trade-off between cost and speed. Because the fastest kinds of memory like cache and RAM are very expensive, while the slower kinds of memory like hard drives are significantly cheaper, computer manufacturers have to use only a little bit of cache to make their products commercially viable. This makes it so that programmers have to keep in mind the speed of these different kinds of memory. You want to use cache to store what you're going to be working on right now, general RAM for what you could use suddenly, and disk for long-term storage. Information is moved between these levels throughout the program to match up with these basic rules. One final note. Cache specifically has a link to multi-core CPUs. In a multi-core CPU, the highest level of cache is not shared between each core. This way you don't always have to use the same memory for your processors, and the memory is not a nightmare to handle as a result. The specifics of how much of each different kind of cache is reserved for each core depends on the architecture. So that's about it. I hope you guys have enjoyed, and I'll see you guys next time.